Good morning guys. Good morning ma'am. We are now in module number 17. We will tackle about the lesson title of Arduino program structure. What is program structure? Program structure. Arduino program can be divided in these three main parts: structure, value or variables, and constants and functions. In this tutorial, we will learn about the Arduino software program step by step and how we can write the program without any syntax or compilation error. Let us start with the structure. Software consists of two main functions: setup function and loop function. Setup function is called when Sketch starts. Use it to initialize the variable, pin modes, start using libraries, and etc. The setup function will only run once after each power up or reset of the Arduino board. After creating a setup function which initializes and sets the initial values, the loop function does precisely what its name suggests and loops consecutive, allowing your program to change and respond. Use it to actively control the Arduino board. So kaning murag box guys is mo na siyang example sa pag-run sa setup dito sa computer. Data types. Data types in C refers to an extensive system used for declaring variables or functions of different types. The type of a variable determines how much space it occupies in the storage and how the bit pattern stored interpret. The following table provides the data types that you will use during Arduino programming. We have void, boolean, char, unsigned char, byte, int, unsigned int, word, long, unsigned long, short, float, double, array, string char, array, string object. First, void. The void keyword is used only in function declarations. It indicates that the function is expected to return no information to the function from which it was called. 2. Boolean. A boolean holds one of two values, true or false. Each boolean variable occupies 1 byte of memory. Example: boolean val equals false. Declaration of variable with type boolean and initialize it with false. Boolean state equals true. Declaration of variable with type boolean and initialize it with false. So murag imo siyang ibutang sa computer. Tapos maghatag na rin siya diretso og declaration if true ba siya or false sa boolean. Number 3, char. A data type that takes up 1 byte of memory that stores a character value. Character literals are written in sign quotes like this: A, and for multiple characters, strings use double quotes A, B, C. However, characters are stored as numbers. You can see the specific encoding in the ASCII chart. This means that it is possible to do arithmetic operations on characters in which the ASC2 value of the character is used. For example, A plus 1 has the value 66. Since the ASC2 value of the capital letter A is 65. Example, char CHA-A equals nang naa siya ana A tas ana dayon. Declaration of variable with type chart and initialize it with character A. Char CHR-C equals 97. Declaration of variable with type char and initialize it with character 97. Number 4. Unsigned char. Unsigned char is an unsigned data type that occupies 1 byte of memory. The unsigned char data type encodes number from 0 to 255. Example, unsigned char CHR-Y equals 121. Declaration of variable with type unsigned char and initialize it with char y. Byte. A byte stores an 8-bit unsigned number from 0 to 255. Example, byte equals byte m equals 25. Declaration of variable with type byte and initialize it with 25. 6. Int. Integers are the primary data type for number storage. Int stores a 16-bit or 2-byte value. This yields a range of negative 32,768 to 32,767 or minimum value of negative 2 to the power of 15 and a maximum value of 2 to the power of 15. The int size varies from board to board. On the Arduino, for example, an int stores a 32bi or 4-byte value. This yields a range of negative 2,174 negative 2,174 to 2,3,483,648 to 2,147,483,647 or minimum value of 2 to the power of raised to the power of 31 and the maximum value of 2 raised to the power of 31 minus 1. 7. Unsigned int. Unsigned ints or unsigned integers are the same as int in the way that they store a 2-byte value. Instead of storing negative numbers, however, they only store positive values, yield a useful range of 0 to 65,535 or 2 raised to the power of 16 times minus 1. The Jew stores a 4-byte or 32-bit value ranging from 0 to 4,294 967 295 raised to the power of 32 minus 1. 8. Word. On the Uno and other Atmega-based boards, a word stores a 16-bit unsigned number. On the Ju and Zero, it stores a 32-bit unsigned number. 9. Long. Long variables are extended size variables for number storage and store 32 bits or 4 bytes from 2147 483 6482 to 147 483 647. 10. Unsigned long. Unsigned long variables are extended size variables for number storage and store 32 bits or 4 bytes. Unlike standard longs, unsigned longs will not store negative numbers, making the range from 0 to 4, 294, 967, 295 times 2 to raised to the power of 32 minus 1. 11. Short. A short is a 16-bit data type on all Arduinos or Atmega and ARM base. A short stores a 16-bit or 2-byte value. This yields a range of negative 32,768 to 32,767 or minimum value of negative 2 raised to the power of 15 and a maximum value of 2 raised to the power of 15 minus 1. Number 12. Float. Data for floating point number is a number that has a decimal point. Floating point numbers are often used to approximate the analog and continuous values because they have greater resolution than integers. Floating point numbers can be as large as 3.402823.5e plus 38 and as low as 3.4028235e plus 38. They are stored as 32 bits or 4 bytes of information. 13. Double. On the Uno and other Atmega-based boards, double precision floating points numbers occupies 4 bytes. That is, the double implementation is exactly the same as the float, with no gain in precision. On the Arduino Duo, doubles have 8-byte or 64-bit precision variables and constants. Constant variables in C programming language, which Arduino uses, have a property called scope. A scope is a region of the program, and there are 3 places where variables can be declared. They are: first, inside a function or a block, which is called local variables. Second, in the definition of function parameters, which is called formal parameters. And last, outside of all functions, which is called global variables. Local variables. Variables that are declared inside a function or block are local variables. They can be used only by the statements that are inside the function or block of code. Local variables are not known to function outside their own. Following is the example using local variables. Void setup, close parentheses and other close parentheses, int x to y. Int Z equals to local variable declaration. Y equals 0, actual initiation. Global variables. Global variables are defined outside of all the functions, usually at the top of the program. The global variables will hold their value throughout the lifetime of your program. A global variable can be accessed by any function that is a global variable is available for use throughout your entire program after this declaration. The following example uses global variable and local variable. Int t and 5. Float c equals 0. Global variable declaration. Void setup. Void loop. Int x and y. Int equals local variable declaration. Y equals 0, x equals 0, actual initiation. We will answer activity number 3, skill building activities. Question number 1. These are the often used to approximate the analog and continuous values because they have greater resolution than integers. Answer is float. 2. It is called when a sketch starts, that is set up. 3. These are the primary data type for number storage, that is int. Number 4. These are defined outside of all the functions, usually at the top of the program, that is global variable. Number 5. Variables that are declared inside a function or block are local variables, that is local variable. Local variable. That is all for module number 17. Thank you.